Okay. So, what the heck? I have these out of order? Oh, yeah, I do. Okay. So, differential equations for diff and Q. There's a whole class dedicated to this in college. If you're going to be a mathematician or an engineer, you typically want diff and Q. You have to have diff and Q thinking. If you're a business calc person, I don't think you take diff and Q. It's not as applicable to business. But if you want to be an econ person, maybe, because those are math-heavy people. All right, so differential equations typically focus on knowing the rate of change. Let's just start from a common place. Differentials are the infinitesimals, dy and dx of things. Okay? So when you hear differentials, think the infinitesimally small delta y's and delta x's, we call dy and dx, which comes from the German creator of the calculus, who is? Leibniz, yes. All right. So he used differentials, his idea. Now, differential equations actually will be equations involving either dy or dx or dy dx. Some college texts will also use y prime as a stand-in for dy dx. The book they use at mine, for example, uses y prime instead of dy dx. A differential equation will usually involve some kind of derivative that's been taken. And when you solve the differential equation, typically it's trying to go back to what is the original. What's the yx equation, no derivative. So obviously that will mean we're going to do what calculus concept if we're going from the derivative back to the original. Integration. You're going to involve integration, but they're very particular, and by they I mean the AP, the College Board, the graders. They're very, and I'm talking the most picky about this concept and how it's done. So pay very close attention about what the work has got to look like, because otherwise you're going to be looking at losing 6 points after taking a lot of work. So follow along with me. All right? It goes like this. Here's a differential equation. dy dx equals x over y. Now I want to solve this, meaning I want to get rid of the derivative and go back to the original. When you solve a differential equation, it means what is the original y-x equation? You might solve for x, but we'll talk about y. We'll talk about that. Sorry. When you integrate differential equations, they are very picky about how it's done. The most important step for AP purposes is to show separation of variables. Now, separation of variables means you're going to put all y's on one side and dy's, and all x's and dx's on the other side. So when I separate the variables, I want to put the y's together. Now let's say I multiply the y over. Y then would be multiplied by dy. And I know it's kooky to see this derivative separated and broken into pieces, but it's very common when we separate differential equations to move the dx over with the x. Now that is the most important step in the whole problem. Because if you didn't show that, they wouldn't even read the rest of anything you did. They would just put a 0 on your paper and move along. Okay? Separating the differential equations. All right? Now, if we then want to get rid of the derivatives, this is a derivative was taken, so now we're going to integrate. This was separate. Now we're going to integrate. When you integrate y dy, then in essence that means you're integrating y with respect to y. What's the antiderivative of y? Y squared over 2, or 1/2 y squared. Either one's fine. Okay? When you integrate x, it's x squared over 2. Now here's the other thing. What about the constant? Would you write yourself a note? Constant only on one side. Technically, you could have a constant on both sides, but the next thing you would do is put all the constants together on one side And so it is okay to write a constant only on one side. Typically, it's written on the x side. Okay? You do not have to have a plus c on both sides. Although you integrated both sides, you could roll the constants together into one. You with me? All right. Now this is called the general solution. It's a whole family of possibilities. A lot of different equations can come together into one derivative. So based on the plus c, that would kind of, in this case, it would really govern what size the shape is and where it's at. But they would all have the same derivative, right? So far, so good? Okay, now if it didn't say then, if it just said find the general solution, then you'd be good. You'd just box it. Sometimes it asks you for more. In this case, for example, if they say, given the curve passes through 2, 4, find the particular solution. Now, when they say find the particular solution, they mean find the plus c. You can do that if they give you an x and a y to put in. If I take the y of 4, put it in, and the x of 2, put it in, that leaves me just the c. 16 over 2 is 8, 4 over 2 is 2, plus c, so c is 6. At that point then, y squared over 2 equals x squared over, did I make that? What? Oh, okay. Yeah, you said where did I find the 6? Okay. This then, that's the particular solution. That's the equation that has a derivative of x over y and passes through 2 and 4. You follow? All right. Last but not least, especially on the AP test, they might ask you to do even one more step, which is decide if it says find the particular solution y equals f of x, then they want you to solve for y as a single function. Now then, that means I need to go back to what I just left off at. If they had asked me to do that, then I would need to do a little more. I need to solve for y. What would you do first? Move the 2. Y squared equals x squared plus 12, okay? Then what? Square root. Now when you square root, we know that it's plus or minus. Y is plus or minus x squared plus 12. Am I done? You're not done, okay? The reason is that a function is supposed to be when you give me one x to put in, I give you one y out. In this, if you give me an x, well, I'd be giving you one y or 2. 2 plus or minus, right? So now, if this is to be a single function, because that is the question they're asking, you must choose plus or minus. Now, it's not really a choice. It's not like, I'll go with minus. It's which one could possibly make or possibly pass through the point 2, 4. Now, surely if I put in the point 4 for y and 2 for x, it's not plus or minus. It must be plus, okay? Must be plus. That's the only way we're going to get a positive 4. If it's the y is the positive root, y is positive x squared plus 12. Now this plus or minus, that plus or minus doesn't always happen. It depends on when you integrate what kind of function you're looking at. You will get a plus or minus comes when you integrate and get either a square, because when you square root, that's a plus or minus, or when you have absolute value. When you dump absolute value, you'll get a plus or minus. All right? That's the process of what a problem will look like. Let's practice it again. Questions so far? Okay, here we go then. All right, consider the differential equation dy equals negative 2xy. Find the particular solution. Y equals f of x to the differential equation with the initial condition of f of 1 equals negative 1. All right? So when they say find the particular solution, y equals, they want no derivative. So you need to integrate, but what's the first thing you got to do? Separate the variables. Separate. So when I separate, I want the y's together, the x's together, and a constant, well, you get to choose. It's up to you which side you put it on. What it would be best, to leave negative 2x on the right side, or negative 2, excuse me, negative 2 on the right side, or move it over to the left side? Well, let's just do the variables first. dy, and how does the y get moved over? Over y. And the right side. Dx gets moved over, and so the right side becomes? Negative 2x dx. It feels like the negative 2 is probably easiest if we just leave it over there, so it's not in the denominator, and it's not a big mess. So let's go with that. Follow? Now let's integrate. You don't have to rewrite with integral signs. You can show both the separation and, hey, I'm going to integrate in the same step, and that's okay. What is the antiderivative of the left-hand side? Be careful. Natural log of absolute value of y, and that's crucial. If you dump that absolute value, you just lost 2 points on the AP class. Okay? And then on the right-hand side, x squared. What about the negative? Negative x squared, and then plus a c. Again, you don't have to have a plus c on both sides. It's just on the x side that you typically put. All right, cool. Now, it's best to use the initial condition. Use the initial condition to find the plus c. So, in this initial condition, it's not given in ordered pair form, so read carefully for what's x, what's y. Is x 1 or negative 1? Which one? Y is negative 1. X is 1. What is the log of the absolute value of negative 1? 0. 0 equals negative 1 plus c. Notice the negative is not in parentheses being squared. It's just the 1 that's squared, and the negative is outside. So c is 1. All right? Put in the initial condition, or not the initial condition. Put in your plus c then. The natural log of y, absolute value, equals negative x squared plus 1. Yeah? Now ask yourself, is this a problem where you have to solve for y or not? In the homework, sometimes you don't have to solve for y, so you wouldn't go on, you just circle it. But in this case, you would, in the question, do I need to solve for y? The answer is right there. The answer is yes. It says solve y equals f of x. You need to isolate y. So, let's do that. How do you get y by itself? E. Okay, you exponentiate. So the absolute value of y is e to the negative. Now, is that e to the this and e to the that, or e to the whole side? It's the whole side. It's just like if you square root. You don't square root here, square root there, square root everywhere. It's square root the whole side, right? Now, this is the part that's probably new. When you dump absolute value, come over here, dealing with plus or minus case. Not every case results in plus or minus. When the antiderivative is y squared or log, you might get a plus or minus. Absolute value. Let's talk about it here. We'll come back to this in a second. Say I told you that some number had an absolute value of 2. What would you know about that number? It must have been or could have been. Could have been 2, or it could have been -2. When you undo absolute value, you have to consider, well, it could have been positive or negative, and the absolute value knocked out the negative. So when you undo the absolute value here, you have to say y could have been either positive or negative. E to the negative x squared plus 1. And that's not a function, now we choose. Based on the initial condition, if when x equals 1, f or y equals -1, we must choose the negative case. The only way we're going to get a -1 out for y is if the function is negative e to the negative x. Choose negative in this case. You follow? All right. Now it's time for you to practice. In part A, it says just find a general solution. So that means you'll have a plus c, you'll leave the plus c, and you do not have to solve. Try part A, please. When I say no solve, I mean no solve for y. Talk it over with your math amigos. Let's see. 4, 6, 10, 14. 8 times 1 person. Who is it?
What's the integral of dy?
Who goes here? Wow, Philip, you should never be a teacher. You're mean.
Well, Chester is not paying attention.
Feels like I'm missing somebody, but I don't know who. This here. She's here. She's here. She's here.
Did you doing some integration?
Yes, 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 yes. Maybe I counted.
Yeah, I'll have my backpack tomorrow. I'm getting it.
Oh, okay.
No, oh my god.
Oh,
My stepmom took my car to the airport while we were on the trip. And the backpack was in my car. So now I have it. No, I didn't purposely do that.
you're great. The first one. Okay. It's a little harder integration. What's the antiderivative of y squared plus 1?
This one's impossible.
Arc tangent of y equals, what's the antiderivative of 2 with respect to x? Ouch.
No,
Seems like that one didn't go very well.
oh yeah, arctan.
I'll give you another minute.
That's not. Oh yeah, let's just go.
don't know about you, but I'm likely to make a mistake on that left side. So, having seen myself screw up the left side a lot, that's how I would do the left side if I were going slowly and carefully. Ready? What's the antiderivative of y to the negative second if I raise it by one power and divide by the new power? Y to the negative 1. 1/3 y to the negative 1 over negative 1, yeah? So negative 1 over 3y if you like. Equals log of the absolute value of x plus c. Now, again, you didn't have to find the c, you didn't have to solve for y. So those are the nicest cases, just general solution. You with me? All right, now in these cases, I'm giving you a differential equation, and I do give you a point with which to find the c, but you don't have to solve for y. So now you're going to integrate, find c, but you still don't have to solve for y. So no solve for y. There it goes. I'm walking around.
Sam had a Sam's got my lunch.
So your final answer should be an xy equation with no c.
When you decrease, you have to decrease it, well, or increase the level, then you divide by. Oh. The 1/3 is still there.
That's about what your work should look like. Find the c, plug in the c. You know, it looks like y is solved for, but it's just how the antiderivative worked out. I didn't have to do anything to get that. On what? The 2 wouldn't matter. You could move the 2 over with the y, and it's fine. If you did, it would look like this. And so it would still be 1/2 y equals, and if you did, it would still turn out exactly the same. It's okay if you move the half. So if you do that, then it's 3/2 equals log of 1 plus c, in which case c is 3/2, yeah? Because you have 1/2 y equals log of x plus 3/2. Yeah. Well, I put in, once I found my c, I put it into my antiderivative. Yeah? Now that's equivalent to my answer if you just want to have c over, so you'd be good.
Why it's super simplified.
Wait, what happened to the
Go all the way ahead. Where?
Wait, what's that?
You are.
So the the second one, my answer is something like 1/3 y cubed equals 2 natural log of the absolute value of x plus a third. Okay? Which you can leave, it didn't say you had to solve for y, so that's the particular solution.
Wait,
You should always, after you find a c, then your final answer is the antiderivative with c in it. So yeah, your ending point should be not just be c is this, call it good. That's not the final purpose. The purpose is to find the final equation with c put in. The last one is a bit of a integration gotcha. I know it feels simple, but is that a function within a function? Yeah, u is negative x, du is negative dx, so negative du equals dx. This becomes something like dy equals e to the u times negative du, yeah? So y is negative e to the u plus c, or y equals negative e to the negative x plus c, and I sub back. So u sub is still a possibility in here. Then use the initial condition, negative 4 equals negative e to the 0 plus c. This is also chosen to remind you that 0 doesn't always mean 0. When you put a 0 in there, does that 0 out? No, it's actually a 1. Negative 1, when you move negative 1 over, c is negative 3. So y is negative e to the negative x minus 3. All right. Last but not least, let's do, this is what we'll do most of the extra practice on. This is what the AP problems were like. Would you do at least the first one, and then we'll move on to questions. Oh, you don't have, do you have homework? You still have 87.
yeah.
Okay.
I don't have it.
Some of you turned in 87. Hey, did you, after separating and integrating, get something like 1/2 y squared equals 2x plus 21/2? Okay? Now, you can see then that this has that final step. You're supposed to solve for y. So what would I do next to solve for y? After I put my c in, I need to solve. What do I do? Multiply by 2. So I get 4x plus 21. Then what do I do? Square root it. When you square root it, it's plus or minus. But then we have to choose. Based on the fact that it's supposed to pass through 1 positive 5, it must be the case that y is positive. 4x plus 21. Square root. Alright, that's the idea. You follow? Actually, I want you to try 1 all the way through on your own. Try, yeah, try, no, actually try this one, please. Try the last one all the way through, solve for y. These, if we do our job, should be layups on the AP test. These are almost always on there, 95% of the time. And they're usually 5 or 6 points on free response. You did? What did I say it cost out? Let's say it cost 4.7 in the letter? You should have cost out 4.5. 7's new, it needs to be done. All right, I'll fix that. Okay, what'd you get for C? Log of 4. You can keep the absolute value, you can dump it, 4 is positive anyway, minus 1. So your equation is this at this point. Yeah? Now you have to solve for y. Okay, so how do you get rid of the natural log? Exponentiate. The absolute value of y is e to the each or e to the all? E to the all. And then y is, with the absolute value of y was this, then y could have been positive or negative e to the x plus log of absolute value of 4 minus 1. And based on the initial condition, when x is 1, y is 4, it must have been the case that y is positive. If when x is positive 1, y is positive 4, we choose positive. Okay? And that's the idea of the day. Are you with me? Okay, questions on set 87?
Can you just scroll down?
87. 15.
2 and 4B.
4B. Okay. 5. And actually, will you get out set 88 for me, please? Yeah, the one I just gave you. Turns out I'm dumb and I had to scratch out the wrong one. So, would you, in box 5 is not scratched out, yeah? Okay, box 5 should have been scratched out, so this is careful. In box 5, will you just change the 5 to 7, please? Because you were supposed to do 7 and not 5. So, in box 5, it should not have an X in it. Scratch out the number 5 and put a 7. You follow? Okay. All right, cool. Here we go. 15. Best laid plans of most. And here we go. 15 is 15 still a question on 87? Okay. Oh, 15, that's a mother. So, it's the mother of all humdingers. It's a humdinger, yes. Okay. 15 actually is the running for one of the hardest problems in the whole text, not the whole set, the whole text. This is rough. So, you're trying to figure out, all right, I could draw an area triangle through this lots of different ways. All those triangles would have different areas. How could you maximize the area of that triangle? In an optimization problem, then you first identify what you're trying to do, optimize, which is to say maximize or minimize. Then if you can, get an equation. I know it's base height divided by 2, but if you're working on the coordinate plane, you should use x's and y's. In this case, then it's xy divided by 2, yay? Where the x obviously is the base of the triangle and the y is the height of the triangle, yay? All right. Then what's the next thing we typically do on a optimization problem? Trying to maximize this area, we would like to get it down to 2 variables, yay? So we need some other relationship. What will that other relationship probably use? The what? Well, we haven't used this, 0.12. Let's assume that they want us to use it in some fashion. So let's talk about that. They also ask, they don't ask, they ask what's the slope of the line.
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
So the other relationship is the slope. Slope of this goes down y over x. That's great. But it doesn't use 1, 2. Now, surely this whole slope has to equal this slope. So I'm going to take the whole slope and say, well, it's got to be the same as this slope. That slope is, y minus 2 over 0 minus 1. Now that's an xy equation. With that equation, you can put the area in terms of x only.
And Ms. Ford will be taking the group of high school students to England in July 2020. Both teachers will host a joint info meeting on Tuesday, February 26th from 6 to 7:30 p.m. in the auditorium. Come find out about both trips and decide which one suits your fancy. Potential travelers and their parents should attend.
Senior high student, are you looking for a good scholarship? Let's go
There's your area equation.
Scholarship workshop.
Now if you optimize it, our quotient rule,
One with a GPA of 2.5 to 2.99.
there's low, too high, minus high, too low.
All winter athletes, please clear out your athletic lockers and bring lunch to Mr. Frico or Miss Italia
Over the square, what's below?
Senior high student, come join Triumph at the Classy Masquerade Ball on Friday, March 9th at 7 p.m. This black tie fair will be Japanese. The dress for the 1920s. Bring a mask and enjoy. Tickets will be $10. Additionally, dance workshops will be offered Sunday, February 25th, Wednesday, February 27th, Tuesday, March 5th, and Thursday, March 7th. There will be paper setup for Mr. White Shirt, so come learn some new moves for the fall.
Okay,
Attention girls
so
golf.
eventually,
Our first practice today. We will be meeting in room E100 to go over schedules, rules, and other details. Please make sure that you have turned in all your forms with the athletic secretary so that you can participate.
Did you know that there are 2 enormous bulletin boards under the TV near the cafeteria? One is for scholarships,
So I have three critical numbers, 0, 4, and 2. Okay? In terms of what this can be though, y cannot be 0 because then there's no triangle there. Y can't be 2 because again, there's no triangle. So y must be 4, it's the critical number. You can prove it's a max area.
$29 at Dublin from 1:45 to 3:15 p.m. Stop by counseling for the details.
Now the slope.
Junior high
If
students.
the slope,
Flyers in the office for middle school tennis, which starts on Monday, April 1st. Practices will be at various locations throughout the week with
if the
matches.
slope is y minus 2 over negative 1, and it must be
Heads up, 8th graders. This week is ICAP with Mr. Northwood.
negative 2.
Today, if your last name is Beasley of fourth
Okay.
please come to the auditorium during
2.
tomorrow. Lastly important, the law.
Dazzling Jack. Congrats to Helen Joe and Emma Richards for their performance in the final round of the U.S. Senior Scholarship. Helen was supposed to take 5 ninth grade.
My baby. Well, go that clock.
Very well done. Congratulate these amazing athletes when you see them. That's all you have.
Stay the same. The second stays the same. All right. Sorry I didn't get to it all. Make sure I get this by the end of the day. Come in. 7th grade, you need to what? I. All right. Stop recording.